We are Group 10, PDP Group 3, with a project theme Ethics and Environment and a title A Greener Approach Waste Management for Biopolymer PHB Production. The content will include an introduction, discussion 1 to 5, and then finally a conclusion to cover everything. PHB, a biodegradable polymer, has gained significant attention as a promising alternative to conventional plastic due to its environmental benefits. However, the production of PHB involves various processes that generate waste streams, such as flue gas and wastewater, that require careful treatment to minimize environmental impact and ensure a sustainable manufacturing process. Effective waste treatment strategies are crucial in mitigating potential environmental hazards associated with PHB production, such as the release of harmful substances and the depletion of natural resources. For question 1, the emission and discharge of flue gas and wastewater from PHB production industrial processes can have several environmental issues. Here are some of the key concerns associated with these emissions. Air pollution. Flue gas emission from PHB production industrial sources contains various pollutants. These emissions contribute to air pollution, which can have adverse effects on human health. Climate change. Flue gas emissions are major contributors to climate change, leading to the greenhouse effect and global warming. This contributes to the environmental and ethical concern, which is associated impact on future generations. Water pollution. Wastewater discharge from PHB production industrial processes often contains a range of contaminants that disrupt aquatic life ecosystem and harm marine life. Human health risk. The discharge of pollutant into water sources can contaminate drinking water supplies and pose risk to human health, leading to environmental justice concerns. Resource depletion and waste generation. Industrial processes that generate flue gas and wastewater often consume significant amount of natural resources, contributing to environmental degradation and depletion of finite resources. As for the ethical aspect of emission and discharge of flue gas and wastewater arises from our moral responsibility towards the environment, future generation, and vulnerable communities. There are several reasons why addressing these concerns is considered ethical. Environmental stewardship. We have a moral responsibility to protect and preserve the environment for current and future generations by minimizing pollution and mitigating the impacts of human activities on the planet. Human health and well-being. The ethical implications of these issues extend to the well-being and health of individuals and communities. Emissions and discharge can have direct and indirect negative effects on human health, especially to concerned communities. Environmental justice. The ethical dimension also encompasses consideration of justice and equity. Certain communities are affected by the environmental consequences and emission of discharge. Ethical consideration also extend to industrial and business activities. Companies have a responsibility to minimize their environmental footprint and operate in a manner that upholds social and environmental values falling under corporate social responsibility. Climate change and integrational equity. Emissions of flue gas contribute to the climate change. Ethically, we have a responsibility to consider the long-term consequences of our actions and make choices that prioritize the well-being of our future generations.
Flue gas treatment by reducing greenhouse gas emissions are important because CO2 is a major greenhouse gas responsible for global warming and climate change. Treating flue gas helps to capture and remove CO2, preventing its release into the atmosphere and mitigating the impact on the environment. As inhabitants of the planet, humans has an ethical responsibility to minimize our negative impact on the environment. This includes reducing CO2 emissions, which are largely a result of human activities such as burning fossil fuels for energy production and industrial processes. As CO2 accumulates in the atmosphere, it acts as a greenhouse gas, trapping heat and leading to global warming. Worsening flue gas pollution can exacerbate the greenhouse effect, resulting in rising temperatures, hotter weather patterns, sea level rise, and ecosystem disruption. Exposure to pollutant can lead to respiratory problems. Acetone is commonly found in industrial wastewater and can have severe consequences for both the environment and human health. When discharged untreated, it can contaminate water bodies, leading to pollution and negatively impacting aquatic ecosystem. Consequently, exposure to acetone can have adverse effects on human health, including irritation of the respiratory system, eyes, and skin. Wastewater pollution continues to occur due to several reasons. Industries that generate wastewater may prioritize pollution control measures due to cost considerations or a lack of regulatory pressure. Wastewater pollution poses significant risk to human health. Pathogens present in untreated wastewater can cause waterborne diseases such as cholera, dysentery, typhoid, and hepatitis. Declining water quality can also impact industry dependent on clean water such as tourism, fisheries, and agriculture.
There are numerous initiatives that can be taken to address and improve the environmental impact of emission and discharge, and one of them is the adoption of best available technologies. Reducing the emission of carbon dioxide from the process units is largely a technical issue. There are plentiful of methods to remove carbon dioxide from the air, such as carbon capture and storage technology, which involves the separation and capture of carbon dioxide emitted from the process prior to releasing it into the atmosphere by storing the carbon dioxide in deep underground geologic formations such as the depleted oil and gas reservoir so that it will remain safely and permanently trapped. CCS technology can be equipped with electrochemical carbon dioxide capture technology, which the supercapacitor store energy by moving electrons between electrodes, selectively absorb carbon dioxide from the other gas components, hence effectively separate the carbon dioxide from the other gases. Only then carbon dioxide is transmitted via pipelines to the underground sites. For the volatile organic compounds like acetone discharged into the domestic water, we can separate them from the wastewater by using adsorptions, air stripping, or biological treatments. For adsorption method, acetone is retained by adsorbents such as zeolites and clays. Air stripping is a technique in which air is intensively brought into contact with the wastewater and causes the acetone to be transferred into the air. Then the air containing the acetone must be treated to prevent air pollution. Air stripping process is only feasible if the acetone concentration is high in water. In contrary, biological treatment is only effective if the concentration of acetone is low. Flocks of variety of microorganisms or algae are allowed to perform either aerobic or anaerobic processes to break down the acetone. The second method would be the enforcement of laws and policies. The Department of Environment in Malaysia should impose the emission and waste discharge control requirements on existing and new plants, with an emphasis on more efficient generating practices and implementation of emissions control methods. Secondly, the plant's operator should conduct regular environmental audits to assess the plant's compliance with environmental regulations and identify areas for improvement. These audits are helpful in identifying potential sources of emissions and discharge, and ensure proper monitoring and reporting. Moving on, plant operators should install robust monitoring systems to continuously track emissions and discharges from the processes. Accurate and updated reporting systems should be also established to provide transparency and accountability. Next, environmental objectives can be achieved by systematically assuring compliance with environmental laws and regulations. In creating system of compliance assurance, environmental inspectorates must inspect the industry to undertake a legal obligation to comply with environmental standards. Non-compliance should result in penalties, fines, termination of license, or even legal actions. Lastly, international cooperation is regarded as a sustainable approach to repair environmental problems and to address governance hurdles by fostering a collective effort among countries to address emissions, water pollution, and other environmental challenges worldwide.
The methods listed previously, such as adopting best available technology and enforcing laws and policies, can be used to resolve ethical and environmental issues associated to PHB production emissions or discharge at various phases of the manufacturing process. Here's when these actions could be appropriate. First and foremost is adopting best available technology. This method is the most appropriate to be used during the planning or design phase of a PHP production facility or during upgrading or renovation of an existing facility. Applying this method early in the design phase could ensure that the production process is initially designed to reduce emissions or discharge. Additionally, it can also be applied whenever a new or improved technologies are added to enable continuous improvement in environmental performance. This is crucial to be applied especially when some of the existing equipment or processes have become outdated or less efficient. Despite that, this method could be implemented in response to environmental performance review. The performance review may help to identify areas where current technologies are not meeting the ideal environmental standards. Thus, quality decisions can be made to invest or implement new technologies to tackle the issues identified. Secondly, when it comes to enforcing laws and policies, this action should be a continuous process throughout the entire life cycle of the PHB production plant. For example, conducting regular environmental audits is necessary in order to assess compliance with environmental regulations and policies. Moreover, establishing monitoring and reporting system would be beneficial to track emission and discharge levels to ensure that they do not exceed the permissible limits. When violations are identified, enforcement steps such as fines or penalties should be taken to encourage the facility to conform to environmental requirements. Moving on is to impose emissions and discharge control requirements. This approach could be implemented during the initial design or planning of the PHP production plant. This is because it is best to integrate environmental considerations at an early stage. As an example, is it useful to assess potential emissions and discharge that may occur during the production process? This way, we would be able to identify source of emission and discharge as early as possible. Consequently, it is possible to implement the appropriate control measures needed. Before the plant could start to operate, it is necessary to acquire regulatory approvals and permits from relevant environmental authorities. Additionally, prior to the establishment of the PHP production plant, it is mandatory to conduct environmental impact assessment. This will help in identifying the facility's possible environmental impacts such as emissions and discharge, and will serve as the foundation for establishing suitable control procedures. Last but not least is encouraging compliance and internal cooperation. This method should be adopted continuously and need to be normalized as an ongoing practice within the company culture. Providing training to production employees as well as having a consistent and effective communication between colleagues would help to promote a culture of environmental responsibility. For instance, from the very beginning, during the onboarding process, it is necessary to provide relevant information or education towards the new employees regarding the company's environmental policies, objectives, and the importance of compliance with environmental regulations. To add on, specific training sessions would be helpful to raise awareness about environmental impacts and how each employee plays an important role in minimizing them. Subsequently, it will improve the rate of compliance within the employees. To summarize, resolving ethical and environmental concerns in PHP production necessitates a comprehensive and ongoing strategy. Early use of the best available technologies, together with strict law enforcement, control requirements, and internal cooperation, can all contribute to reducing environmental effects and assuring ethical behaviors throughout the manufacturing process lifecycle.
Alright, thank you, Azza. So now let's move on to question 5. Where would these actions be implemented? The actions may be taken in different sectors and industry to consider the ethics and environmental considerations for adopting the best available technology, enforcement of rules and policies, imposition of emissions or control requirements, as well as promoting the compliance and cooperation. The best available technologies may be used by manufacturers and production facilities to minimize the impact on the environment and reduce emissions. The utilities and power plants can invest in cutting-edge technologies to produce energy more effectively and with fewer emissions, as enforcement of emission and pollution control laws is essential for the energy sector to fulfill its environmental obligations, where enforcing the strict emission and discharge control standards can aid in the reduction of pollution and the protection of ecosystem. In addition, the encouragement of internal cooperation and adherence to environmental regulations inside transportation corporations can result in a more sustainable business practices. The ecosystem can be protected by enforcing rules and regulations that restrict the hazardous agricultural practices, such as the overuse of pesticide or fertilizers, where the water pollution can be avoided by imposing discharge control restrictions on farm and food processing plants. The regulatory agencies can play an important role in the enforcement of environmental laws and policies to ensure that they are complied with on a global scale. In the consumer goods sectors, the encouraging compliance and internal cooperation within businesses can foster innovation and success. There are several strategies or methods proposed in PHB production plant waste management system, including the carbon capture and storage, to treat the flue gas which is implemented at the outlet of the bioreactor with molar flow rate of 1886.18 mole per second and the mass flow rate of 53,962.83 kg per second. CCS is equipped at the discharge of the accumulation reactor that operates at 500 kPa and 40 degrees Celsius at stream 11, which is highlighted in purple color. In addition, the gasification treatment unit is equipped at the discharge of centrifuge 2 as the biomass waste is collected as the feedstock prior to the gasification process as highlighted in the blue color. In conclusion, more ethical practices may result from promoting adherence to moral and environmental norms, as well as encouraging collaboration between farmers and food producers. The regulatory agencies can play an important role in the enforcement of environmental laws and policies to ensure that they are complied with on a global scale. In the consumer goods sectors, encouraging compliance and internal cooperation between businesses can foster innovations and sustainable practice.